Hello and welcome back to the stream. I am Junchan, and today we are going to change things a bit. The format so far has been that I've been, when I started streaming regularly 3 times a week after I was streaming every day, I shifted to this format where I'm doing something different every day of the week. But I get the feeling now that to be in the proper headspace to make better progress, I should actually work on the same project 3 times during one given week, and then shift to another project on the next week. So yeah, so basically it means that I suppose it means that there's now a schedule that's in fact disconnected from what we have on our workbench. And we could try and specify what we're doing per week, like here we're March 16th. So, and what I decided is somewhat, well, it's not completely arbitrary. It's because I feel like that's where I've been making a little bit of progress, and I'd like to continue building on that so that we actually have some results. So what I want to continue trying to set up is the GStreamer the GStreamer editing services with Haskell, and in such a way that we can maybe hopefully plug it into an FRP engine on the top. So that's what I'll be doing, GStreamer and Haskell for the week of, well, I suppose, is it the week of the 16th? It's the week of the, yeah, I suppose it's the week of the 16th to the 22nd, right? Okay, so that's the plan. And in fact, that's what we were doing in the previous stream on Saturday. So where we got was that I was almost able to run Cabal Run Streamline, which is our current executable name or program name, with an NKV container, but it was missing some codecs that clearly seemed to be in the GST library. And I thought a bit more about this, and I did a bit of modification here. Basically, I realized that it probably didn't make sense to declare the system dependency here. Probably also maybe extra libs would have been a better way. This way, it wouldn't have tried to find the GST lib. But instead of doing that, I actually decided, for now at least, to basically declare the extra libraries not in the Cabal file, but in the Nix file. I don't know. Thinking about it now, it seems like maybe it would be better to actually define it in the Cabal file. But it works. So that's the good thing about it. So now we can run this without an error. Right, so it says running, okay, without an error, right? It doesn't mean that it's actually working, because there's obviously, as you can see, and also as I can see anywhere, no video playing, and so that's obviously not exactly working. I'm leaving it running to see whether it's actually going to stop by itself, but it doesn't look like it is. And the reason why I'm trying that out is also because, in fact, if you do run GST play in the Nix develop shell here, that actually works. That starts up a GST play window, and it plays the video. And also, after a while, this is a short video, it just reached the end of the playlist after 10 seconds, and then just shuts itself down. So we have our GST tooling good to go. I should probably also just try one of the MP4 videos just to double check that actually indeed we can run this. Yeah, Cabal Run Streamline, that doesn't work. I'm also going to try MP4 video here, just a sanity check. Yeah, it looks like it's doing something, but we don't really know. So it's a good occasion to dig a bit deeper into the GST binding side of things. Finally, doing some Haskell code. And I remember trying to do this earlier on, but here it seems like it's chosen a particular image sync, the XV image sync. Here we ask for an auto video sync. So one of the things I suppose I could try is to run a GST pipeline with GST launch that has exactly those settings and see whether that actually works. And I think that's something we tried a while back, but yeah, not recently enough for me to have this in the shell. But let's do GST launch, and then let's do file src with, I suppose, location, home, right, June videos, and let's use 1954, why not? And then what's the syntax? It's not pipe, it's what is it? Just escapes me right now. Completely forgot. Totally blanking out. GST launch 1.0 and whatever. Basic tutorial might have been a better idea. Pipeline description, and oh yeah, of course, bang. I knew it was something a little bit like a pipe, but yeah. So I think we picked up Decode Bin 3 from looking up, debugging the GST play, and looking at what pipeline GST play was assembling, if I remember correctly. But let's just try. I think none of these actually use any parameters, and then auto video sync, which I suspect is probably what is causing the problem. But let's try this. So this is actually working. So yeah, I'm using a view such that this is actually what I'm seeing. I'm overriding the browser window. So okay, so that works. So let's see. So GST launch is obviously providing, I think, some logging here, but I'd like to have some logging from our Haskell code. So let's find out how we provide some settings to the GST library, gi.gst, such that we have a little bit more logging, and hopefully are able to troubleshoot like this. So let's see, log, no such thing here. Okay. How are we going to find that out? Where could it be? Could it be the main loop? That's a possibility. I gotta say that I'm not... The fact that we launch the pipeline by setting the element state here, but then we do run loop, and using this syntax that I'm actually not very familiar with, it's overloaded labels that allows to do hash. And I think it means that loop is a record, and that we select the run label from the loop record. So let's double check that, and that will teach us a little bit about what the loop is. And so main loop, that's not even here. How come? GStreamer bindings. Oh, that's from glib. Right. That's from the, I guess you could say, parent library in some sense, right? So one of my questions is, could this run without glib? Let's remove the references to loop. Out of the main loop, clean up nicely. I wonder what this will do. Let's give it a shot. It's possible that it won't work, that actually we need to explicitly control the run loop. Ah, right. Yeah, we do need to explicitly control the run loop. Okay. So that's one thing we know. So let's head to the glib documentation on package glib, and I suppose here doc index and main loop new is what we're doing. Right, so I remember us taking a look at this, but let's look more closely. So it returns a main loop, and the main loop has a main loop constructor, and has manage PTR and main loop. So it's not the type I was necessarily expecting. Main loop new returns an M main loop, so loop should be a main loop, but then we use run on it. So I was thinking we would have there is a run, there's a run function, in the main loop struct. I would be expecting to have some kind of label. Edge pointer. Is label run? So for some reason, so is looks a bit like this, right? But it's not exactly this. So let's look at the source code. And run. Without run is running, but there's no real run label that I can see. This seems to expect some is label instance, which is also what I was looking from the overloaded label documentation. Enable the use of #foo overloaded label syntax, a format identifier whose interpretation may depend both on its type and on its literal text. When the overloaded label extension is enabled, an overloaded label can be written with prefix hash, for example, #foo. Type of this expression is label foo a to the constraint is label foo a to a, and the class's label is defined as blah. And but I don't see any. Oh, there is. Okay, so that's the label. There's a from label which calls overloaded method. This is interesting. It looks like it's kind of an attempt to do object-oriented style with Haskell idioms. So we're really calling the run method on the loop object, and the main loop is a class and it has methods. This instance apparently is used to resolve main loop methods, and the main loop run method has some info and like a dispatch table right there. Wow, this is strangeness, but yeah, it's really strangeness. No but. Okay. So Now, I suppose let's try and get a sense of whether we can learn more, not necessarily about the main loop. I mean, we can run it. We can have a ref to it. I don't think we need to get into that. Let's look at pipeline. Let's see if we can pass some stuff to it. GST flags. We can pass pipeline flags. And there's only those. Works with a fixed clock. And that's pretty much it. There's some parse flags. Path template flags. Okay, maybe we look at the example code again, and right, those were interesting, but we don't need the next stuff anymore. That's all good. Okay, codec documentation, we don't need. This also, I think we probably will get something quite stable. It's Haskell.nix for now. And yeah, I think we can close this too. This as well. Yes, we wanna keep this because I'm still very much interested in understanding what approach Oskar Wikström took to make the GTK interface more declarative rather than this very imperative way of doing things. So I think we'll learn more about these weird idioms maybe. GStreamer daemon, that's for later. And we have GST hello world. So that's the example that we lifted. And I suppose this is supposed to, hey, one. I did see you from the corner of my eye there. Yes, I absolutely need to add a pin comment for chat. Yes. Is there a special thing, or do I need to program it? The way that I'm doing this is a little bit relying with pretzels. Oh, really? Interesting. But you know, yeah, actually my current setup doesn't even really allow me to listen to pretzel very much. This is what I actually see in my screen. And that's how I actually make sure to keep an eye on whether there's some chat, but it's not foolproof. It's definitely not foolproof. Yeah, it is a bit too small, but if it's bigger, then it obscures my screen. So yeah, not the best. Definitely some improvements still to do, but I've been good. I've been very good. I decided to make a little change. I was announcing at the beginning of the stream to, instead of changing topic every day that I stream, you know, I stream 3 times and I pick a different topic. I decided instead to continue with the topic for a week and then shift to the topic to a different topic the next week, because I feel like I'm at this stage where I need to get a little bit more immersed into the code of each of the projects to move them forward better. So that's kind of what I've been up to. But Nix is getting much more stable, and yeah, I'm glad that I'm not doing Nix now. I'm going to be doing some Haskell and GStreamer, which is really what I want to do. So it's really good. How about you? How are things with you? Diving into the matrix, always. It's where I live, right? Right, yeah. So I wanted to try to actually get that bus call back, because I'm wondering whether that's actually somewhat somehow needed by the loop logic. So bus call was actually called up there, right? The message handler. Seems logical. Oh no, sleep. Yeah, when sleep doesn't go well, then things suck. Oh, nice. Nice to hear. When sleeps get better, everything gets better. Yeah, well, I'm glad you're out of it. Yeah, when sleep is not good, it's really not easy. How has my sleep been? I've been feeling a bit tired. I think the movement in weather, it's been alternating between kind of nice and a bit still cold, and I think my body is like, I hate this thing. Like, I want to just go to bed. So I've been taking naps. That's been helping. Oh wow, hold on, is this already compiled? It can't be. I need to rebuild this. What? Do I just need to main HS deleted? What? Oh right, yeah, indeed. I'm not tracking SRC. Well, that's strange. And so if do I need to exit mix develop maybe? No, I shouldn't need to. Although I suppose maybe I will need to if I change the git state. Naps are wonderful. Naps and bath. That's my recipe for keeping healthy, especially when it's cold out. And I also take cold showers in the morning. That I think also has been helping a lot, actually, to get my body not to be lulled into a false sense of oh, I'm inside, therefore I don't need to think that it's cold out, and then with a little bit of cold, then you like catch a cold or something like that. That used to happen to me all the time, but now I've been doing cold showers in the morning during winter, and I mean, not the whole shower, like just a minute or two. Yeah, it's also a good mental exercise, actually, because I don't like it. Obviously, after like nice moment in the hot shower, you're like, oh damn, okay, this is time. I need to do the cold shower thing. But it's and then obviously it's like, it's just 1 minute. It's good for my health. It's unpleasant, but it's also training me to take just a little bit of unpleasantness and be able to deal with it, self-inflicted unpleasantness, but that's in fact good for you, because I really believe that it does something positive to the immune system. So I can accept rationally that it's the right type of suffering to self-inflict, nothing too bad. I'm not a crazy I don't like to mistreat myself, right? I'm gentle with myself, but 1 minute cold shower, I can deal with that. Okay, why doesn't it recompile? This is weird. This is really weird. There's something that doesn't work with my Cabal setup then. Do you have SRC, other models? I wonder. Well, you don't have the data to back that up, because you need to try for, like, I mean, first of all, you need to, I suppose, be sensitive to catching a cold once in a while during the winter, and that definitely used to happen to me. And I can tell after doing this for a couple of winters that it has reduced the incidence of that to pretty much not getting a cold at all. So I guess your mileage might vary depending on whether you get any cold or not. Git tree is dirty. Yes. Why? Okay, I suppose I could add everything to my Git. I mean, maybe not the DRenv stuff. I don't suppose that you're not supposed to get the DRenv stuff. So and git restore .drenv, right? Staged. Right, and then I'll add DRenv in the git ignore. Don't get sick much. That's good. Yeah, I know. You know what? It's not because I used to happen to me also when I was younger. So okay. Yeah, let's get that git ignore and let's commit. Working flex setup. I don't need to git push. Let's just exit that and nix develop again. Okay, I mean, let's check my, I am using the Cabal thing, right? I'm using Project Prime, okay. Okay, and then Cabal build, oh, is it? I can't believe that. But I suppose it's possible. I just don't believe it. Yeah, no, it's not true. So is my Visual Studio Code playing some tricks on me somehow? That's also possible. Engine.hs. I'm now running the loop, so so it shouldn't just do this. Okay. So this development setup is still not right for some reason. What's outputs? Nothing special. What could it be? Flick.nix, why is Flick.nix not? It says modified here, doesn't it? Oh, stage change. What's the change? Don't see any change. Ooh, that sounds nice. Is it ice cream weather? Has it started to be nice again down in Texas? After that crazy snowstorm stuff. Ooh. Nice. Yeah, nice. Enjoy your ice cream. Yeah, it's definitely not ice cream weather yet here. Okay, so what's going on? Source is dot. I suppose source is not really dot anymore, but I don't suspect that that would be the problem. In fact, it should be more about the Cabal file, right? That should be the one that picks up the change in SRC. What would Cabal tell us about stuff? Cabal has Nix integration. I didn't even realize that. New style projects. Cabal info, maybe. I don't think I should clean. I guess I could check. Yeah, nothing too bad. More about info. You can't find JC. Because I'm not in a develop shell. Yeah. Yeah. Package requested. There's no package name Streamline. Is it Streamline XE Streamline? File does not exist. New classes. Oh, that sounds good. Oh, 2 weeks, that's long. Yeah, I should get new glasses too. I don't even know if the opticians are open in Berlin these days. I suppose they are. Yeah. Yeah, I was actually fixing my glasses with super glue just a couple of weeks ago. Again, in fact, they've been holding with super glue for a while. All right, there you go. Or is it the nose? For me, it's the ear stuff. It's the branch. Okay, I have no clue what's going on. Why would Cabal not pick up a change? Yeah, that looks fine. Main is main HS. Main depends on engine and model. Okay, let me put some change in main, see whether that works. Yeah, that actually works, and that triggers the recompilation of engine. Okay, so I'm clearly missing and doing something stupid, I think, with other modules. I think it's probably not other modules. Okay, Cabal file. That's not. How come this is the best result 1.22? I think we have version 3.4. Yeah, we do. Package name, setup.hs, exposed modules. Maybe it's not other modules, it's exposed modules. Let's see whether that does it or not. If I change account with what? Account with account function? A cout with a cout function. Is that what you mean? What's a cout function? An object of class or stream. You display the output of standard output device. stream text output. Right. So it what does it do? Does it segfault or does it blow up the stack? Does it just hang your computer if you do something like that? You does her. Not at compilation time, right? Though at runtime. It doesn't tell you why, right? Yeah, the art of reading impossible error messages. Yes, okay, it works. So these modules are needed for compilation but not listed in your Cabal files or the modules. Judah, why do I need to put them in other modules if they are exposed? Because it's an executable. Right. So it does need to be in other modules, but if you're not going to recompile it, then I'm not going to put them in other modules. Oh, don't understand. Oh, a compilation. Well, that's nice. Oh well. Yeah, so now you're still okay. And so if I uncomment this, okay, now you compile it. So I think you were just yeah, I'm not sure what was going on there, but now it's running, but it's leaving right away still. I'm not sure why. Thanks. Enjoy your ice cream. And yes, drinking. I actually don't have water next to me. I'm gonna go grab some. Enjoy your time and ice cream one. Good to see you again. All right, so I think the file system, there must have been some trouble for Cabal to detect that there was a change in the file, but maybe now it's fine. I mean, at least it's okay recompiling this, but I don't know. It looks like maybe it hasn't recompiled engine, in fact, because no, it's compiling it right now. Okay. But for some reason, it gets to end of stream right away, which is a message from, in fact, the bus stuff. And so it gets to, why does it get to end of stream? And are we getting all of the error messages? I think with this, I was trying to get all of the messages. So if the first thing we get is after state playing, after writing running, the moment we run the loop, we just end the stream right away and then return. Then I suppose there could be something wrong in how the pipeline is written. So we need more debug here. And there is a way to get a whole load of debug from pure GST pipelines. Debug, right, GST debug. So let's see whether it applies to Haskell-based or foreign library calls of GStreamer. Doesn't look like it does, right? So if I do the launch and do GST debug equals star, well, actually, I don't see any debug here either. So is it star colon star? No. GST debug. Category level pairs. If GStreamer has been compiled with some flags, so debug log, what car is available? GST debug equal a number. Okay. So let's try 5 for debug. Okay, that works. And a bit of a crazy output, and then let's try here, and it does work. Okay, very good, very good. So maybe too much logging for us. Yeah, it's actually still going through, I suppose, the registry. Let's just do info, I suppose. If we can ever get some control back. Let's dump that shell. Not as fast as I would hope. Nix develop is supposed to be super fast, but I think that the fact that we use Haskell.nix means that the combination is actually not as fast as if we didn't, because it's doing a bunch of, I think, what's called IFD interpretation. What does it mean already? Doing derivation, Nix IFD. Import from derivation, right? The import from derivation mechanism is in some sense abused to do a whole bunch of checks, like installing stuff. Right, so let's do 4 instead. Still going to be a lot, but there we go. Feels a bit like we should be in a slightly more sizable shell, I think. GST equal 4 and cabal run streamline and home June videos and 1.mp4. Boom. Okay, so what seems to be the problem? Let's try and find running in here. Right, I don't know the keyboard shortcut. Running. Here, running. So just before running, pipeline is not live. So just before running, it's actually not necessarily running. Finding a bunch of plugins in the registry, it looks like. All these MIME types there. File src. Opening home June video 1.4. Okay, that looks like important. Base src. Pad not activated. File src again. Opening the same file. Info task. Setting stream lock. Okay. Create some task. Complete the state change. Notify about state change. Ready to paused. Ready to paused. Parse bin 0 changed to paused. Complete state change. Notifying about state ready to pause. Pending. Is it doing this? Right. It's doing this for type find, which I think is just trying to find the MIME type. Parse bin, which parses the result. Decoder, some queuing. I think all of this is in decode bin, including the queue, decoder, and then video player. And then it says pipeline is not live. Video player, I think, is how we call it, right? Yes, that's the name of that's the actual machine name of our pipeline. It says pipeline is not live. And then we display running, and then we ask to loop. So we expect that then, so it looks like it's doing some type find related things. To finish my sentence, I said we'd expect it to try and go live at least after running, since the loop then gets ran. But let's see whether that's the case. So it loads the plugin. GST type find. It looked like it did already an awful lot of GST type find before. It's strange that it's doing the plugin loading only there, but maybe type find loads the plugin, because it seems to be loading some video QuickTime ISO, and so that would make sense, maybe because it's MP4, maybe. Then the element has some pads. One of those is src, and so it seems like we actually link src to parsepad. Okay, I'm not sure exactly, that's part of the negotiation between elements, but I'm not entirely sure where it is. But here GST ISO MP4 is loaded, so clearly we've loaded the plugin that we found, and then we created the pipeline is able to automatically know that it needs to add a QTDMux element. So it seems like it's doing regular things. Maybe it's not live, but it's kind of setting itself up before being able to be played. So could it be that we need to pause before we launch? I don't know. So QTDMux parses a bunch of metadata. And then it's trying to get range, but that doesn't work. Video X264 is loaded here. with some very specific settings, including a frame rate of 24 drop or something. So it's QTDMux configuring itself. Including loading an H.264 parser and trying to link these things. So it's really still setting up the pipeline. So there's something there, maybe, because it printed running, but clearly the pipeline is very much still being set up. So maybe we requested a state playing, but it's, while we're here, it's definitely still not the case yet. The back of my mind, I'm now wondering whether all of this is properly compatible, or if the API has changed at all with the current version of GStreamer we're using. Oh damn! I lost us. No, not so much. We were quite close to the bottom, in fact. So yeah, things are still being linked. Okay, what I wanted to do was GST, like inspect, for instance. I need to take the next step up here, and that's fast. GST inspect version. Yeah, we're 1.18.2. So yeah, we reconfigure stuff. Still negotiating formats. Pads appear and are being linked to each other. Some stuff goes from ready to paused, which is interesting. That has no peer. H.264 parse. Pad has no peer. Pad has no peer. And then adding pad src0. Adding new par. Release segment event time. Segment start. Offset stop 0.45 seconds. That sounds credible as the duration of the RMP4 file. Let's launch it with GST play here. "45 seconds, that's correct. 45. Pad has no peer, so latency upstream tags. So still some negotiation. Pad being dynamically linked. Multi-queue. Reconfiguring emit autoplug continue. That's decode. The decode bin. Reuse caps. Reload libav for the AVDC H.264 plugin or decoder. Configuring, adding a video pad, and then a bunch of stuff that says the AVDEC H.264 is going from null to ready, pending paused, and then null to ready still pending, and then ready to pause and then complete the state to pause, and then notifies that it went from ready to pause, and then that ends the stream. Okay, so let's compare that with doing GST launch of file src. I suppose we have it here. That's the bash equivalent of, or I believe is the bash equivalent of this exact same pipeline right there. Just need to GST debug 4, and that's not at all what we wanted. GST debug 4. Okay, that runs and we stop. Okay, and running. All right, don't know how to search, still running. Come on. Really? Did you blow up the... No, you didn't. Is it easier because I Control C it? Oh, but no, of course there's no running here. It's not the Haskell code. Okay, so let's see if we can find something similar here. It's deleting the pipeline here. Oh, it does something with the image, but I suppose, hold on. Right, it does do quite a bunch of stuff after it closes. Okay, I need to search for end of stream right here. So we received that end of stream event. Is it really the case? Or is that premature, and is there something different in the code about how we detect EOS? So message types, okay. So I suppose we could maybe also put the line, maybe show message types. Or print, sure. Okay. Okay, end of stream. There we go. We have message type EOS, message type warning, message type extended. So we've got a bunch of message types, but we don't have the message. How about we get the message as well? Sounds like a good idea, no? An instance of show for message. Okay, let's try and see. It's a glib struct. Yeah, no, it's a GST struct. structs message. Get message type. I suppose it would probably be closer to where get message type is. So let's go check out the index and get message. All right, so we have all these things. Mini object. What's that and what can we do with it? I see. Yeah, there's all these interesting syntaxes for this sort of object-oriented overloaded labels thing. Simple structure, ref counted type. It doesn't look like it has a show instance. Get message mini object. So I suppose maybe we have mini object, get memory, get mini object dispose, get mini object type ref count. I don't know. Get query mini object. No, that sounds like that's a specific type of mini object. Mini object. Yeah, all of these different things. Mini object. Not great. Message type. Type error. Have a type warning. I suppose we could try and get that type warning, can't we? But then the question is, yeah, I suppose we then need to do something such as message type warning. And then message parse warning. Oh, there's details. Sounds great. Let's get the details. And then, right, then what's this return? An M structure. Who knows what that is? Let's just get the warning. Check out that G. Oh, that gets a G error. Okay, well that's good. That's all the same types, except that we don't quit, right? That's the only difference. But we can show, and we could say that it's a warning as well. It's very nice like that. And I think all the rest should be, in fact, the same. So let's give that a shot. See whether it tells us more. And end of stream. And well, suppose I need to search for warning, right? Warning column. Oh, it's not going to be easy. Did I just click too fast? I think I did. Oh, what? No, we don't need that one. But that's the ones we have. So apparently we don't touch that code. Although I gotta say, I'm now worrying just a tiny bit about how this loop behaves with things that I think risk being asynchronous. Yeah, so that's a little bit of a concern. We'll put this in std. Let's just make sure. Ah, yes, correct. Is it correct? Message parse warning. That seems like that's something that comes from, yeah, right, message type, JStreamer type. So I think it's a type mismatch. I think we actually, maybe we need a G warning. Message, is there such a thing? There isn't. Okay, let's check out message parse warning and make sure we're getting the right stuff. That's supposed to be from GStreamer, but right, doesn't show up here, but hopefully will show up in the whole thing. Yes, it does, and that's, yeah, returns G error and text. Can I main loop continue? GST message parse warning. Search engine message type message equal message warning. Failed. So message type warning is one of the message types. Do we even get into that code? It's not clear. Or use after free bug. Aha. Yeah, that sounds possible. So it could all be timing related. Can we add something? Let's try and simplify this a little bit. Yeah, still. Yeah, I suppose if it receives an EOS as part of the warning, then maybe in fact we should parse it here. We should be able to, because otherwise we match on type warning. And maybe we missed the EOS. What's the shot? Yeah, same. So probably just yeah, just because of our attempt to try and parse everything here. Let's double check that we don't run into this error again. If we remove the code, just sanity check. Yeah, okay. End of stream. And this indeed is sort of moving about. It's not necessarily happening always at the same time. Here it seems like it's happening earlier on, but we can't trust the order of these logging messages also because the GStreamer logging debugging facilities also have nothing to do. All this might run in different threads, so we can't really. It's not deterministic, the ordering. Which also means that it's unclear still why the pipeline goes to null. When does it? So it starts removing things, dispose, and found pad. It's still trying to link some stuff. It's successful. But it's receiving an event on the flushing pad. On a flushing pad. So does this mean that the pad's actually on its way to being gone? There's some stuff that gets unlinked and removed right there. Yeah, everything gets unlinked at this point already. So this is already, the pipeline is already being torn down here. Stuff's going to pause. Still linking here. But here it seems like already an event's received on the flushing pad. The decoder changes to ready. The multi-queue goes from pause. So this seems like that's an attempt to actually move the pipeline from pause to playing, which is the desired state. And change to ready successfully. Desired next ready changes to ready. Pause to ready. Caps filter changes to ready. H264 parse desired next to ready. Upstream parse. Ready. Sync, resume from pause, and then boom. Removing pad video 0. Why? And then starts unlinking. Unlinking video and parse. So that's So, you know, it could be that that I set up this pipeline also incorrectly. That's also completely possible. So let's see if we can learn more about how to build pipelines here. I suppose I should check in this code which worked, if we can find something a little bit equivalent to at least I suppose something like, yeah, child h26 parse change to ready. That sounds like a good thing to search for. Yeah, we do have some. And yeah, right here. And then it starts unlinking as well. Oh. So maybe unlinking is not a problem. I suppose it depends on when it happens, but yeah, it's removing path video 0 also just after task resume from pause as well. Am I looking at the right thing? Yeah, I am looking at the right thing. And links the code 3 bin. So that's, I'm not sure, but it doesn't link multi-queue. Why does it unlink all this stuff? Task resume from pause. First thing it removes is path video 0, which is the same as here, removing path video 0. And then a whole bunch of unlinking. I wonder whether that's actually normal. Well, I mean, it seems at least it's doing the same thing in the case where it works, including all the way to here, where it finds a fake video sync pad and it tries to link stuff. So I suppose maybe all of these pads are needed at the beginning to do content negotiation, and then some of them are just then flushed after that. Okay, maybe that's the way it goes. So yeah, it tries to link. It also same thing, finds the pad and tries to link it and say that it linked it, and then from there goes on to reconfigure some stuff, which is again same thing, same sequence here. Only thing that changes is that there, I don't think it is this whole ref counting things. There is. So dispose finalize. Huh, there is, but not for XV image. It looks like the actual sync XV image thing. We don't have any of, no, we do have it, but it just came in a different order. But this is all removing, and after that, completely state change to null, freeing pipeline, and unlinking, and done. So I suppose, yeah, but all that stuff happens, all of that stuff happens after I've actually closed the output window. So it is not negotiation and then it gets flushed. That's what I thought, like these pads are actually used for data transfer. So what's going on? Here, yeah, obviously the pipeline is going to playing, which has not happened. in Haskell, so why not? libav gst libgst libav loaded. Let's should have the same thing occurring in the regular pipeline. And indeed we do. And then what does it look like? Well, I suppose I could open this into a different window. Maybe. I don't think I can actually. Oh, damn. There we go. We have this, and then we will create a new terminal window, and we will go into Streamline, and we'll mix dev up, and we will run the GST launch pipeline with the GST4. So we'll launch whatever we have here on the command line, and we'll close this and well close this, and we'll pick this guy here. All right, there we have something a little bit comparable side by side here. Should be easier to parse, hopefully. Okay. So indeed, yeah, a big difference here. Upstream tag list. libav is outputting some data here, and I don't see any of that happening here. It just unlinks right away. So even though we load GST-libav and create the elements, try to link things, but here we say adding pad video 0, which happens here, but just after that GST pipeline kicks in here, it says try and delete linking one pad, some pad of GST decode bin 3 name decode bin 3 0 to some pad of GST video convert name video convert 0. Prepare and then full link decode bin to video converts successful. We don't get any of that. We do get some video decoder thing, like with just one. All the rest here is GST states. So looks like decode bin maybe doesn't properly connect to video convert in our pipeline. Could that be the case? Decode bin to video convert, that would mean plugging in decode to conf, and we do link decode to conf. So what decode conf sync. But I wonder if I should try to use a different decode bin here just to see. Ah, we get an error here. Reason not linked. GTD max. Yeah, I wonder whether it's possible that when we use this bang pattern, that it's something more happens than just linking at the API level. So let's go and search for some information about that. GST launch. Oh, there's a GES launch. I didn't know that. Very relevant to us. But for later. Pipeline description, links. So the bang syntax is termed link. Links the element with name source element to the element with name sync element. Names can be set on elements using the name property. Username is omitted. The element that was specified directly in front or after the link is used. This works across bins. A bin after bin type is created and the given properties are set. Element between the braces input into the bin. Aha. Dot has to be used after the bin type. If a pad name is given, the link is done using that pad. If no pad names are given, all possibilities are tried and a compatible pad is used. And it's possible to put caps in between to filter things. Caps are a sequence of properties or can be added to with semicolons and pipeline control. Okay, now let's look a bit more at the GST linking, the element link, and maybe also at the examples, right? I think we were heading for examples a little bit earlier, and that's GST hello world. Let's put it at the end here, and so hello world obviously is supposed to be simple, but here it didn't use element link, it used element link many. So it connected the source to the demaxer manually, so to speak, and then used element link many to link decoder, conv, and sync. Decoder, conv, and sync. And then finally, on pad added of the demaxer, then connect to the decoder or something. On element pad added, on pad added. On pad added is this. It takes a GST element and a pad, such that if you give it the decoder and the pad, you can now link this pad with the Vorbis decoder sync pad. Linking demaxer and decoder. Does this have to be in fact a dynamic link? It's possible that in fact it has to be. That maybe this bank syntax actually deals with it, but because this error message that we're getting and the fact that we were missing the what we were seeing in the healthy pipeline was the linking between was it this one? GStAV. Yeah, the delayed linking one pad of GST decode bin 3 to GST video convert. So decode bin and video convert were linked in a delayed manner, and that's the bit that was missing. So decode bin and video convert. So let's see whether we can actually reuse that logic to say, instead of so decode and convert, which is exactly what we're missing here. So we'd say what, something like this would be conv and this would be decode, but yeah, we then just need to make the onPad added logic there, because it means that the decoder, I suppose, dynamically discovers formats, and therefore only when the format is discovered then adds a pad, and then this onPad added then dynamically links it when the pad is found. Well, I like the theory. Let's see whether the practice matches our expectations. It doesn't, at least with the decode bin. Let's try and switch back to the decode bin 3, since that's what we were trying to model. No, still not. And let's go back to the code here. Source demuxer decoder conf sync. So all are in the pipeline as bins. Here only the source is connected to the demuxer. Then decoder to conv and conv to sync. So here have source to the decoder, and then this is only for an audio output as well. Here we're trying to apply this to video. I don't know if it makes any difference. Source to demuxer. And I assume this does decoder to conv and conv to sync. Yeah, it clearly does this. And then onPad added to the decoder, which is the, oh, right. So no, there's an inversion here. It's the demuxer is the upstream one, the decoder is the downstream one. In our case, the decoder should be the upstream one, and the conv should be the downstream one. Or not. So Gmuxer will be linked to the decoder dynamically. The reason is that OGG may contain various streams. For example, audio and video. The source paths will be created at runtime by the demuxer when it detects the amount and nature of streams. So therefore, we connect the callback function will be executed when the pad add is emitted. So that's similar, but it could be that there's actually more dynamic aspects to the pipeline that we're trying to reproduce here, because we're trying to do a bunch of automatic things, and it could be that there's more. And so maybe we can spy that by looking at delayed linking in the log here. That might be the right keyword for things that. But no, there's only one. It's adding path video 0 to decode bin. So on element pad added of decode should be firing when that thing appears. I suppose let's run this again with the debug level and see whether it at least attempts to do something a little bit similar. Okay. And what are we doing? Oh, I realize now that you can't see the thing that I'm comparing when I've been comparing. So I'll just remove my little chat box detector, which is not working very well anyway. Okay, so trying to link decoder video 0. Okay, received event on flashing pad. No, I don't think that's it. Prepared and full. I don't see anything that relates to the decode bin. Yeah, there is. Get output for slot. It could be that the decode bin actually doesn't add the pad dynamically. Delayed linking one pad. Trying delayed linking one pad, some pad. RGCT could be in 3. One pad, some pad. Element decode bin 3, any to element video convert 0, any. Let's see if we have anything like this. Decode bin 3 -0. We don't have any decode bin 3-0 for some reason. We have decode bin 3. Okay, brought us back all the way down. Okay, I'll reset here and run this and group in 3, adding pad sync. Let's see what the logic of on pad added is like. Dynamic pad created. So do we even get this? We do. But it's trying to link decoder video Right, of course. It's not named decode bin 3 because I gave those names that are different from the actual names. So which, to be honest, maybe is not the smartest, because then I think it will rename them with -0, I think is what GST launch does. Decode bin 3, video 0, and video convert sync. So it does try to link those, and in the corresponding here, delayed linking, GST decode bin 3 name decode bin 3.0, trying to link element decode bin 3.0 any to element video convert 0 any. And here we link specific things. We link decode bin 3 video 0 and video convert sync. So that looks exactly like what we would want, and it looks like it's actually also successful. So I suppose the other potential thing that's going on is that there are more dynamic linking going on in the pipeline. But when we try to search for delayed, we didn't see anything. There's only one delayed thing in here. So the other big difference is that libav doesn't bring back any info. So despite GST libav being loaded, libav itself doesn't report anything. And that's kind of where things diverge, right? Like GST event occurs, GST states are modified, but here, end of stream right away. Whereas here, video decoder, actually there's a redistribute latency message that's passed here. Could it be that we shouldn't quit on this end of stream message? Shall we just ignore it and just carry on? Ha! Yes! Yes! We succeeded in running a GST pipeline from Haskell code. Wonderful. So for some reason, we have an end of stream message coming up, but we shouldn't bail out, and not clear why. Yeah. Could be that yeah, no, I don't have any idea why. So we'll need to understand that next time. So let's log some of this stuff. Yeah, will be, I suppose, in the streaming logs. And right, we are gearing towards instantiating a GES pipeline in Haskell. We'll also want to try, maybe even before, in fact, try GES launch. And yeah, today we launched a simple GST pipeline from Haskell, and we did that. It's amazing, super happy. And so next I'm thinking we want to understand why did this pipeline send an EOS? Why understand why the simple pipeline sends an EOS. Yeah, actually, I want to read about also sort of, I want to start doing this now, in fact. Take a look at Oscar's blog post on wrapping GTK, because I think that's something we need to do fairly early. And here it is, not here. Um, 22-minute read, but let's take a quick look at it, see if what applies for us. APIs of GTK plus became problematic. So it's not given that the GTK library that binds to Haskell GI is anything like the GST library. So I suppose one question is, where are the GTK in the Haskell GI package? Okay, so they are in here. Haskell GI, GTK. Why is there no document? No link to the documentation. Well, hold on, Haskell GI is not where we use. No, it is where we use. At least GI base. Then GI GST is somewhat on top of that. So is it GI GTK then? Ah, yes, I think it is, because GI GTK declarative is the one that Oscar built on top. Yes, and it depends on GI GTK, correct. And GI GTK super looks exactly like a GST library. So we are completely we have a big parallel here, except that obviously everything is going to be about creating widgets and whatnot, and we're going to need to mentally adapt that to the idea of building up pipelines, and therefore also thinking about what the declarative equivalent of widgets will be like for pipelines. Okay. Widgets are created, properties are set, callbacks are attached, and methods are called, all in I/O with imperative style. Instead, there being two distinct phases of a widget's lifecycle to be handled separately in your rendering code. One, construction, where you instantiate the widget with its initial state, and 2 subsequent updates, where some relevant state changes and the widget state is modified to reflect that. Often the application state and the widget state are the same. Right, okay. So I think we can definitely establish a parallel. In fact, I'm kind of wondering whether we shouldn't start a library here. Can we give a name to that? Because I suppose it would be then called GST declarative or something like that, right? Stack is possible, but it's not even, there isn't a, it might be inside here. Cabal file, indeed it is. Yeah, I think we need to create a separate thing if we want to go that route. I don't think we can name things, but okay. So it might be overkill to try and do this right now, but we should at least somewhat, yeah, I suppose replicate a folder hierarchy that will look like that. So have a, is it GI capital? It is, and then folder GST, and then we'll do something like a declarative file here. That would just import stuff, right? Yeah. And then there would be a declarative folder. And well, then we need to decide what our top level things are. Surely there'll be pipeline and whatnot, but let's, there's also bin here. That's a bin. GTK.bin, a bin widget, a widget with exactly one child. I see. I wonder whether that's the same conceptually than a pipeline bin. A bin of type mid type. Pipeline description, right, so it is a recursive thing. So no, in this case bin can contain pipelines, but we'll have probably bins at the top and pipelines and such. We can probably in fact start without any of these stuff. And indeed we could do this, and container widget I think is the main, one of the workhorses, right? But yeah, construction and subsequent update, I suppose we would have the same, setting up the pipeline and then maintaining the pipeline while it's playing, which could mean actually dynamically modifying it, which is possible, but also dealing with sending control signals and receiving events, which is the whole dynamic aspect of it, which I'd like to plug into something like Deny or Rhyme. But I think before we do that, we probably want to make it more declarative and then hook the declarative layer to Deny or Rhyme, maybe. This programming style makes testing and locally reasoning about your code really hard, as it forces you to scatter application logic and state over IRFs, MVARs, and various callbacks, predicting shared state in I/O. Symptoms are not specific to GTK+, or its Haskell bindings, but are common in object-oriented and imperative GUI frameworks. If you're familiar with JavaScript and jQuery UI programming, you most likely experience similar problems. While GTK Plus has the Glade WYSIWYG editor and the builder class, they only make the first phase declarative. You still need to find all widgets in the instantiated GUI, attach event handlers, and start mutating state to handle the second phase. After experiencing these pains and getting repeatedly stuck building fastcut, that's the previous name of Compose, with the imperative GTK Plus APIs, I started exploring what a declarative GTK Plus programming model would look like. Going declarative. The package I've been working on is called GTK Declarative, and it aims to be a minimal declarative layer on top of the GTK Plus bindings in Haskell GI. Rendering becomes a pure function from state to a declarative widget. Okay, so that's a very well-known pattern, and so how do we think about this for our pipeline? First of all, rendering is not exactly the correct concept here, the correct vocabulary. Instantiating or playing or running might be better. Because we're one level higher than the actual management of the data going through the pipes. So, I mean, we might have some, that's going to be interesting, right? Because there is a static view of a pipeline where the static aspect is just how it's wired, but in fact, bytes are streaming through it. But now I'm wondering whether we can keep this abstraction tight, in the sense that if I want to play with time and this idea of while streaming, directing some ongoing result of the stream towards certain buckets in the GS timeline, or clips in the GS timeline, whether that somehow would mean that we need to surface the data, the point-wise stream level dynamism or updates, or because in the most case we'll have more macro level changes, like this clip ended or this clip started, or maybe some automation occurs, but not a frame in the stream has been sent. We want to delegate that to GStreamer, so it'll be very rare when we want to deal with each frame. Each clock tick is another way to say it. So yeah, I think we can definitely start. Let me write this down with an idea where, yeah, we have a declarative pipeline, and so not rendering, but let's transform this text to. In fact, I suppose we can write it here. In GTK declarative, we have this. I mean, in essence, this is really from here, but rendering becomes a pure function. Here, playing or running becomes a pure function, a pure script, a pure function from state to a declarative pipeline. I think that's sensible. Which is a data structure representation of the user interface, right? So declarative pipeline will be indeed a data, exactly what we want, a data structure representation of the user interface. The library uses a patching mechanism to calculate the updates needed to be performed on the actual GTK plus widget. Oh, okay, yeah, that kind of makes sense. Based on differences in the declarative widgets, similar to a virtual DOM implementation. That's quite interesting. Oh, I'm looking forward to that, because for us, it might be graph patching might be what we end up having to do, which will be fun and interesting. But it could be that instead of like a more general graph patching, it could be that we restrict it to like a matrix routing patching, which might be a subset. It might be, I don't know, it might be expressive enough to actually express any graph. It might actually be equivalent to an adjacency matrix. We'll find that out, and also see whether which encoding is actually more amenable to patching. That's going to be interesting. And I'm definitely going to want to look at like things like alga, right, like the algebraic graphs. Patching mechanism, yeah. So updates needed to be performed on the actual GTK widgets. And so yeah, the level of granularity of the graph also, because there's going to be the routing aspect of the graph, but also the vertex mutation aspect of patching the graph. And so to change the properties, like which file you open, for instance, right? That could be mutating the source or the location property of your GST element in real time. And so detecting that there's been a modification in a vertex property set, if it's some kind of map or dictionary of attributes, then we end up having something like a leafy graph or like a document graph, where vertices have GST element properties, and then if we diff those things, well, there's going to be the possibility to diff those things, or to then also piggyback on signals and what are signals going to be. And that I don't know yet so much about how things are done, but we could try how things are done in GStreamer for that. So I'm like, for instance, if we pick up like something like file src, file src location, tag reading, why would that be? Okay, yeah. There we go. Right, so location, exactly the example. Right, it's a property, and it has read-write capabilities. So we should be able to dynamically change this. So that's a good example of something to try. Which is like this kind of switching, right? So that's not it shouldn't be too hard to do that. In fact, it should be fairly, well, actually I am kind of curious on how you do that with the declarative syntax. Probably GST element set property. Okay, I'm going to write this as something to do in the next stream, like dynamically change an element property like file src location with the imperative API. Okay. And here. Event handling is declarative, i.e. you declare which events are emitted on particular signals rather than mutating states in callbacks or using concurrency primitives to communicate changes. So here we're saying, in our case, I think we're saying, with the event handling will be a mapping from on one hand, signals to depending on what we use at the type of approach we use for events, I mean, probably some kind of event data type, right? And it's probably going to be a like a base functor for free monad, basically. Or or maybe it's the co-free. Maybe we do it interpreter bias. I don't know. That's something we're exploring in the PureScript world, but might be worth looking at here. But although in this case it might also just mean hooking them up to a as a sensor for Dunai or Rhine, sensor actuators. That would be the other paradigm. And then I'm wondering whether property changes are going to be part of that or not, because I think in the GES pipe, GES timeline and so on world, all of the automation stuff, is that all signals or is some of that properties? NGST editing services. And something like a GES clip. And okay, yes. Yeah, things like time effects. No, time effect is manipulating time, which is exactly what some of the Dunai and Rhine stuff is doing. So quite interesting to map those concepts. Properties, GS clip, duration limit layer. Okay. Virtual methods. So clearly not properties, or at least it seems like it's very simple. There's only 3 ones, and they're more like macro style properties. Macro level. create track element and track elements. Create multiple core. Okay, maybe a track element then is going to be something that's belongs to a single GS track. Yeah, I think that's the intersection of a clip and a layer in some sense, I think. And signals, control binding. No, that's adding and removing control bindings. Properties, track types, changed, active changed. I think I need to look at things like transitions. Transitions. Order, invert, and properties, v-type. Default value is crossfade. Are you telling me that this is a linear crossfade and that there's no way to change the curve? GS type transition clip. Get type. Yeah, no, that's its type. We're gonna need to map the whole GS stuff actually, aren't we? There's going to be, I don't think any of the GES stuff is linked. So that's going to be a whole other thing. Generate bindings for GES. Yeah, that's going to be a big thing. But there's something I don't understand here about. Oh, right. Is it that I think there's something that all of these things inherit from? The NLE maybe? What used to be NLE at least. That means that they all have animatable properties. Is that even right? Not so sure anymore. Okay, how about an effect? A rate. Change the rate at which media is playing. Okay, so that's a time effect. That's time overlay. Alpha. Ah, okay. Hey Jesse Cogolo, thank you so much for the follow. Really appreciate it. Do you do some Haskell yourself? Frequency of the test signal, height. So I assume that all of these things are animatable, but I suppose I'm not completely sure. I think it would make sense that they would be. And then we'll be, that's going to be a whole other interesting thing, right? Which will be how we map the glib loop and with the Rhine clock, basically. That's the main thing. And GS version plugins. Are these GS plugins? No, they're just yeah, they're just the GStreamer plugins, so that's all good. Right, because we're in the API reference. Okay, yeah. Extractable interface, what is that? Extracted from a GES asset. Interesting. Oh. Yeah, I'm not sure what that's meant to be. Requested asset is extracted. Is it just a, does it mean compressed? Some kind of compressed asset? GS extractable. Get asset has been set on the extractable object. Get ID of some associated asset. Sets the asset for this extractable object. No, not quite clear about what this extractable business is. Okay, it doesn't have to matter right now. Okay, let's go back a little bit more into the juicy bits, the declarative, and let's not go all the way, but let's go just a tiny bit further, because that's the really super interesting bit. So event handling is declarative, right? I guess that's what I was wondering here, if there was something else than signals here. So what properties are animatable, or even are properties animatable in GES? I suppose we want to find out also in just GStreamer basic whether there's whether properties are also mapped in general. Like read by properties. I mean, if that's the case, yeah, I suppose like even something like time code, right? I mean, we might not want to like, well, how about time code, right? Yeah. Interesting. Then clocks might play into this again. Declare which events are emitted on particular signals, rather than mutating states in callbacks or concurrency primitives to communicate changes. Events of widgets can be mapped to other data types using the functor instance, making widgets reusable and composable. yeah, that's probably the kind of base functor approach, I would imagine. Finally, GTK declarative tries to be agnostic of the application architecture it's used in. It should be possible to reuse it for different styles. That's great. We shall see later. There is a state reducer based architecture available in GTK declarative app simple, and Fastcut is using custom architecture based on index monad and the motor library. Ooh, sounds fancy. Finite state machine. Ah, right. Hence the index monad. That's cool. That is definitely another point in the design space there to think about complex interacting states. Definitely want to take a look at this at some point. By reusing type-level information provided by the Haskell GI framework and by using the overloaded label language extension in GHC, GTK declarative can support many widgets automatically, even though some widgets need special support, specifically containers. It is a massive benefit not having to redefine all GTK plus widgets. Single widget. A single widget, i.e. one that cannot contain children, is constructed using the widget smart constructor, taking a GTK plus widget constructor and an attribute list. Note that button and check button are constructors from GI-GTK. They are not defined by GI-GTK declarative. Right, so it takes the widget. Let's try and draw parallels here. That's GI-GTK, and a button is a GI-GTK object, so is check button. And what's our equivalent GST situation? We have objects including pipelines. Yeah, wonderful. So well, the main thing that will be varying, and that might be somewhat equivalent to this widget construct, is going to be the element for us, I believe. Let's try and pull those side by side. Element, I think that's going to be the main thing. Here widget gets past a button, gets past call button, and many of these things are widgets. But I think in our case, so let's see how the parallel be drawn. If a widget can be widget button or widget check button, then I suppose, well, first of all, we might, well, yeah, there's two ways to go. We could restrict, we could narrow the GST world to something that's a bit less of a smaller surface that fits our application, or we could try and stick to the GST API surface, and it sounds like it would be obviously more reusable or better contribution to the ecosystem if we actually made this reusable or stick to this API. But I don't know whether there is an equivalent to a widget that would group several of these GTK objects here. It could be that in our case we actually have a one-to-one mapping between all of the objects here and maybe the declarative constructors that will end up being in the declarative version. Plugin. Let's look at our engine code again. Here we're making elements from their the system name. That's very inelegant. We might want to that might be something that we end up having to do, which is a kind of a taxonomy of, or a typology of plugins, because we see here that some of them might have pads added dynamically to them, and that will impact whether we need to listen to pads in order to link things automatically or not. So it will impact the imperative code. If we want to stay completely declarative, then we'll have to somehow annotate some of these things to with their dynamic nature at least, but we might also annotate them based on whether they are sources and sinks, so which leans towards more of indeed a kind of a more formal directed graph denotation. And so that might be reflected in the types of these, and so we might actually end up having maybe we'll end up having file src and decode bin 3 instead of file src and decode bin 3, such that file src will be a vertex, a source in the, is it in the graph sense, in the directed graph sense? I suppose so. So ideally we want that the type level representation of these things is such that we can't represent invalid states, right? Which, by the way, might be a use case for an index monad, actually, for a slightly different reason than a state machine, but still one where actually you want to coerce at type level which combinations are possible or not. And index monad might be exactly what we want to use. So maybe an indexed monad abstraction would be the right one. It could be that in fact we even want to go categorical on this, maybe, but that's really about sort of the graph representation again, which connects to also how the patching will occur and what's the properties of the vertices and whatnot. Okay. And yeah, so then bins, and therefore what things can be children of others here, and then yeah, what things even can contain more of those things. Containers often accept any type of widget to be added to the container. In GTA declarative, on the other, containers restrict the type of their children, right? So that's exactly the type of thing we want to do, except that this is all going to be tree style declaration, which is often what is the case with a UI, a graphical UI data model. But now here we want to declare to find representation that allow to declaratively specify a graph. And so it could be that arrows are also something we want to take a look at, maybe. And arrows, of course, being what is used in Dunai and Rhine, but maybe like 3 arrows, maybe like somewhat. There's some stuff to look at in there. And then comonads, don't think so, but maybe because of the data flow, the essence of data flow programming. Okay, and what am I doing? I don't know is the answer. And attributes. Other class replication have attributes. Right, so those are labeled vertices. And yeah, that's a very standard pattern. We actually use something like that in the PureScript React Explorer and PureScript React Basic. And properties are mapped to the GTK object properties. Ah, right, so that's where you use these. Oh, that's cool. That is quite a cool way to build these things indeed. Huh. Yeah, property declaration. So I think we're probably going to be able to lift this pretty much verbatim. We'll probably find, so we'll want something where when the framework goes and introspects file src, somehow it knows that it has a hash location thing that we can set to a path. Actually, we'll want these things to be typed, maybe. That's going to be quite a lot of work. Yeah, I suppose we'll do a subset of the elements that are interesting to us and see where we take that. Then events are also attributes. It's an on attribute, and then you can specify it. So that's cool. If we can make signals behave like that, that'd be really cool. Yeah. We can say like vertex properties, and then somehow we'll connect them in some ways that makes sense. Maybe in a way similar to how you build the pipeline in with GST launch. Maybe we want to, wow, no need to shout. Maybe we want to aim for a GST launch pipeline style syntax, i.e. something like file src location colon equal whatever path something, right? We'll need some, reuse some stuff for path, and maybe with some like on start. How is it then? Then some kind of event, right? Then show play status or something, show playing status, and then we'll have something like a bang and like a decode bin 3 with nothing, and then another bang, and then some stuff, and then we can look at other syntax that's like that. I mean, I remember hearing that in the early stages of when Linux was built, that there was a more evolved graph piping syntax somehow. I'd like to take a look at that. But otherwise, yeah, the bin, I think, is the composable mechanism here. So if we say my bin dot and then some sub pipeline, then we can reuse that in a pipeline. So it relates to composability of pipelines, which relate to composability of graphs, directed graphs, in fact. So again, we can look at Alga again here, right? And on M, what's that? On M, some events need to be constructed with IO actions to be able to query underlying GTK plus widgets for attributes. Oh. Get color button RGBA has a color button to IO, maybe RGBA. So we compose it with an fmap and the color change construct to get an IO event. I see. Right, so that's kind of a dynamic events language of sorts, and we're probably going to need something like that as well. Very cool. Yeah, like for instance, for us, it would be maybe on status change and show status, but composed to get status, something like that. Let's write something like that. On M, change status. Show status of get current status or something. Okay. And CSS classes. And then this is a simplified state reducer design. And we should probably have a little bit of a similar thing. Right, so that's the imperative version, which looks quite a lot like ours. Well, that's not really true. It's actually pretty clean and nice, even if it's imperative right there. Right, so there's a view and an update and some inputs and an initial state. Very typical indeed. And yeah, we need to think about what that looks like for us. An example like this. So I think that's where I'll stop here. I'll just put a task to do this in here. When imperative API, yeah, and then continue work on declarative GST bindings or API, and in particular write a simple conversion of the hello world example. Hello world example is not a very good example for this, but you know, we want to say like the declarative GTK example. Okay. That sounds like a good program for next time, and that's where I'll leave you for now. We'll see each other on Thursday for some more fun with Haskell and GStreamer. Oh, so happy that we got finally Haskell to run some video stuff. Yes. So super happy about that. Thanks a lot for following, and I'll see you on Thursday. Bye bye.